Hello and welcome back to the Banana Chip Tech YouTube channel. My name is Sam and I'm excited to be here with you today to talk about the coolest blast parser of 2021. So one of the questions that I get a lot from pre-health and health professional students is how do I actually use this coding stuff in what it is that I do. I wanted to show you this blast parser which directly uses Python programming to develop an effective biotech tool. So today we're going to be talking a little bit about the program and how to run it. If you're interested in seeing how it was coded, stay tuned because on Wednesday we'll release a video documenting the entire process of coding the blast parser. Okay, so let's talk a little bit about what is BLAST, and why do we really care about BLAST. And so BLAST stands for the Basic Local Alignment Search Tool. And so BLAST basically finds regions of similarity between biological sequences. And it compares nucleotide or protein sequence to sequencing database and calculates statistical significance. So as you can see, there's multiple different types of blasts, right? There's a nucleotide blast, which looks at nucleotide sequences and compares them to nucleotide sequences in the database. There's protein blast, which looks at protein sequences and compares protein sequences to protein sequences in the database. And then there are additional programs. There's like BLAST-X, which takes translated nucleotides and compares them to protein sequences in the database. And tBLAST-N, which does the opposite, where it takes protein sequences and it compares it against translated nucleotides in the database. There's even more BLAST programs. There's like SciBLAST, MegaBLAST, all sorts of BLAST programs that are optimized to do specific things. So I'd highly recommend you checking that out. Look, I have the source here. So again, this is produced by NCBI. Okay, let's go ahead and run into an example where we're comparing DNA sequences to really kind of understand what it is that BLAST is really doing, okay? So let's say we have these five sequences here, and so we're trying to determine how similar are each of these sequences to this first sequence, right? So we'll go ahead and we'll say we want to compare how similar these are to the first sequences. So in BLAST terms, what this is basically saying is this is the sequence that we're using as our query, and then these four sequences make up our database, right? And so our database contains these sequences, and we're trying to compare how similar this sequence is to the sequences in our database. But let's go ahead and figure out how similar each of these sequences are. So this first sequence, if we compare it to the second sequence here, we find that A and G are not equal to each other. So we get a dash here. A and G are not equal to each other, another dash. A and G not equal to each other. A and T not equal to each other. But finally we get T and T, that's equal to each other, so we have a match, and then so on and so forth, right? And so we can say that we had, out of the 10 base pairs in this sequence, 60% of them matched up, and 40% did not match up. So we can say this is 60% similar to this first sequence. Now we can do the same thing for the next one. We can find that this one has 70% similarity. The one after that has 0% similarity. It's not similar at all, and so on and so forth. So based on these results, we would say, oh, well, sequence number 3 here is 70% similar to sequence number 1, and sequence number 2 is 60% similar, right? So let's say we have our little virus that we found, or a soil sample, or whatever you want it to be, out in the world somewhere, and we've sequenced it, and we've gotten a sequence here. I've only put a few of the base pairs here, but recognize that these sequences are much longer than just this, or they can be much longer. And then what we're going to do is we're going to use the sequence as our query. We're going to query it against the database, which is what BLAST is doing. It's going to query the sequence against our database, and then it's going to return to us the similar sequences that we would get. Okay, so now that we've kind of covered a little bit about how do we compare DNA sequences and find their similarity to each other, and also talk about what BLAST actually does, give an example with that virus. Let's talk about what the results of BLAST really are. So there are 5 result parameters you're going to get if you run a BLAST search and get some information back out to the user, right? And so the first one is the max score, which gives you the highest alignment score. Then you get the total alignment score, which is the total score from all alignment sequences. Query coverage, which is the percent of the query that was aligned to the database sequence. Mapped identity is the highest percent identity of all query subject alignments. So our next question, is what is identity? And so identity is the extent to which two nucleotide or amino acid sequences have the same residues at the same positions in an alignment. And so if we go back to our example of comparing DNA sequence, that percent that we were getting would be our max identity. All right, and then the E value is kind of where you start getting into the statistics of this. And the E value is the best or the lowest expect value of all alignments in the database. And so that kind of begs the question, what is an expect value and what do I really care about an expect value? And so the expect value is a parameter that describes the number of hits one can expect to see by chance when searching a database of a particular size. It decreases exponentially as the score of the match increases. And so it basically describes the random background noise. And so I'm getting this information from the BLAST website. There's some frequently asked questions on BLAST, and I'll link all of these resources that I'm using to create this video in the description below so that you can read it, as well as link to some other videos such as that might actually help you get a little bit better understanding of what BLAST is and how it works. Now, one of the biggest problems that people have, I guess, people think that E values are actually P values, and they're not. And so for the sake of brevity, I'm going to skip over the discussion of why P values are not E values, and instead link to you the BLAST statistics in the description below. So if you're interested in figuring out why is an E value not a P value, please check it out. I just wanted to mention that they are not the same thing, and you can't exactly use them as such. BLAST is a really frequently used program in research. I'm just doing a search through PubMed. I found this article that's looking at coronavirus, another article that's looking at fungus, blight resistance in wheat, then a error-free genome assembly, infected body fluids, next generation sequencing, and then assembling of a cattle reference genome. So as you can see, BLAST is something that's used quite frequently in research. If you want to get started with BLAST, what you can do is go to the BLAST website, and you'll get a screen that looks something like this. In this website, you can select the type of BLAST you want to do. You can do BLAST N, BLAST P, BLAST X, T BLAST N, T BLAST X. Enter the query accession numbers, and then select your database, select your organisms, etc., etc., etc. And there's a whole lot of other parameters that you can include as well to get your BLAST search. And so as a researcher, this is a really useful tool, right? Being able to go to the website and run BLAST. But sometimes it gets frustrating when you're dealing with a lot of DNA sequences that you need to check one at a time, or you don't have access to internet connection, or all sorts of other problems that could go wrong with using this website. Also, I think the BLAST website changes every now and then, so you might have to adjust to the changes in how the website looks. And so that's where the BLAST parser comes in. The Coolest Blast Parser, as I've been mentioning throughout this video, it really allows you to take out some of the complexity of this thing and get down to the bare bones of what it is that we're trying to accomplish. What the BLAST parser does is it allows you to create your own database that you want to run your queries against, and then query the database in an automatic fashion. Simply just type in your command and hit run. So with that being said, we're going to jump into an example of using the Coolest Blast Parser of 2021. And so what I did is I went to the NCBI website. I'm going to just pull it up right here. All right. And in the NCBI website, they have the latest link of SARS-CoV-2 nucleotide sequences. I downloaded a session list, and we get this list here. And so what I'm going to do is I'm going to go ahead and run BLAST by creating a database with those sequences that were stored in this ACTXT file. So all of these sequences, and then run BLAST against each of them to see what happens. So let's go ahead and do that. And please keep in mind that whatever results I get here, this is just for testing purposes. Please don't take any results here too seriously. Okay, so it turns out that there were 10,000 sequences, and it was taking too long. So I decided to cut it down to about 500 sequences and go ahead from there. We're going to go ahead and make DB again. So I do want to mention that what we have here is the Blast executables that we downloaded from NCBI. So these contain all of the different types of blasts. So we have our blast N, which is the one that we're going to be running in this trial here. Blast P for proteins, blast X, delta blast, psi blast, T blast N, T blast X. So all of the blasts, there's a make blast DB. Yeah, so all these blasts are contained here, and we got these from NCBI. So what this parser really does is it just takes these sequences that we've gotten. Well, first of all, it takes a list of sequences that you've received from the database, and it will download all the sequences to your file. I think you've seen that I made a few modifications here, like I set this to only do 500 or so, just because the sequence list that I had like 10,000, and instead of waiting here all day, we just cut it off to the first 500 or so and went from there. But this we can remove afterwards. And then just to make sure that it created the database, I commented this stuff out. But now that we're good to go, we can uncomment it. And so now it's doing its blasting. You'll notice that in this results.csv file, we're getting all of the hits. And so this CSV file, what's great about this is it allows us to take one sequence and blast it against the database, and then take another sequence and blast it against the database. This is much more easy for us to do. We can customize it to do exactly what we want it to do, which we can't exactly do in the website as easily. And so for that reason, I think having your own blast parser, it's a pretty convenient thing to do. And so I'm going to keep letting it running, but as you can see, we're already down at like 320,000 lines here in our code here. So I'm going to go ahead and actually stop the video here, but I hope you enjoyed this tutorial about Blast and kind of an example of the use of this Coolest Blast Parser. Stay tuned. On Wednesday we'll have a video where we walk through the coding. You'll see the code being written in like real time basically, and you can see like the process that went into building this.